All right, so today we're going to talk about LOLBAS and how one of our researchers introduced new techniques and a new approach to actually living off the land binaries and scripts to our platform. I'm not going to talk about the platform itself, but just know that everything that I talk about here is how the approach that we took to adding these new things to the platform. So first things first, that is not me. That is actually the researcher that started this project inside Pentera. His name is Nir Chaco. He's an electrical engineer. He's from the IDF and a security researcher. And last year, he was tasked with adding new LOLBAS to the platform. Again, if you're not familiar with LOLBAS, I'll talk a little bit more about what it is, what it can do, why you will probably want to do it. And again, he's the one who started this project last year. Who I am, Nelson Santos, also an electrical engineer, former pen tester, purple teamer, and then recently turned to the dark side of sales because it pays much better. But I am now part of the principal sales engineer at Pentera. All right, cool. So living off the land, as you might know, is to use the binary scripts and whatever resources you have on the box that you got a shell on or something like that, right? So obviously, ideally, you would upload something like an interpreter or some other shell or some other payload that would allow you to have a lot of other tools at your disposal, but that's not always possible, especially on a machine that might be locked down, might have EDR or things like that, and that's where LOLBAS comes into play. Okay? So again, LOLBAS stands for living off the land, binaries and scripts. And the idea is to use whatever you have on the box to do something. I mean, I'm old enough that when I was pen testing, sometimes you get it to a Windows box, you have CMD, that was before PowerShell even existed. And how do you go then from there to downloading other tools? Perhaps you want to download something to extract hashes or just to give you a better foothold on that box, to do reconnaissance, whatever it is. But you need some functionality to be able to do that, and that's where LOLBAS comes into play. Now, a lot of different things you can do with LOLBAS. We have the alternate data streams, compiling code on the box itself, copying files. But I guess the most common use case would be to download, again, other binaries to the box, and obviously execute them as well. Sometimes you might not have a full shell on the box. You might be able to execute some commands, but you don't have an actual shell that you can interact with. So ideally, you want a tool that will be able to allow both things to happen. Again, it can also be something to dump hashes, to do whatever you want, to encode a payload, nowadays UAC bypass and things like that, and even to upload data to yourself. But this talk and what we were looking at when Pentera started looking at the problem was to do two things: to download something to the machine and then execute whatever that was. Right? That's what this is about. LOLBAS is really important because it is a very easy way to stay under the radar from EDRs and other tools like this. I'll talk more about the prerequisites that we had when we were doing this research at Pentera. But basically, the idea is to use tools that are signed, ideally actually from Microsoft as well when doing this thing. Obviously, you can do this on Linux, whatever you want. Oh, no, on Linux, you probably have other options anyway. But on Windows boxes, you might have PowerShell restricted, whatever, and you might not be able to do it. But it's really important, and I think it's a tool that will be interesting for every pen tester. But again, the goal of the talk is not to talk about specific LOLBAS, although we'll go over some examples, but it's to talk about how we approach the problem of finding new ways to perform LOLBAS. So the goals, again, is to, for red teamers, pen testers, researchers, to find the next unknown LOLBAS. As I said, our talk is going to concentrate on Windows, but you can do this with any operating system. And more importantly, we're concentrated on Microsoft signed payloads or OS native payloads, binaries and scripts. But again, this can be used to find any other types of LOLBAS as well. For blue teamer, again, same thing, to find the next LOLBAS so you can defend against it, right? So you can actually put controls in place to either stop this from happening or at least detecting when this type of attack is happening. But more importantly, we're going to talk about the approach. Pentera, if you don't know the platform or what the company does, I recommend you stop by our booth to understand what we're doing, but it's basically automated pen testing. So it's about automating as much as possible of the pen testing process. And so the techniques that we use to actually find new LOLBAS, they're also going to be automated. And this is the actual goal of this talk. And this is just a joke that you put there, right? Low isn't so funny when it comes to binaries the best, but anyway. So I guess one of the best known places to find LOLBAS is the Office suite. It's very complex, it has a lot of components, and it does allow you to do a lot of different things. Like, again, downloading different payloads, downloading different data, whatever you want, upload data. And the actual LOLBAS project started with Excel. We didn't start the project, by the way. You can go on GitHub and see more about this. Just a compilation of a bunch of tools that allow you to do that. It's actually a pretty cool project. And you can search for specifically binaries or specific functionality that you might want. So you can say, give me everything that can do downloads and things like that. Again, extremely useful if you're doing a pen test or even for some CTFs and things like that. So what was the initial approach that Nir took? And actually, he was working by himself at this point on the project. And it was really brute force based. Let me list all of the binaries that I can find on Windows, and then let me compile a list of those and try them manually, right? I mean, it works, but it is extremely time consuming and error prone. And as most of you know, hackers are very lazy. I mean, I guess you can spend 10 hours to create a script that would actually save you just 1 hour, but still, you're gonna go that route. And that's what we ended up doing. So he did a list of the binaries. This is just a very small sample of what was found on the machine, obviously. And again, this would actually be filtered even more to be able to account for binaries that are not Microsoft-based or not signed, binaries. Because again, we want to stay under the radar of EDR and whatever other tool that might be trying to protect against those attacks, right? So we'll see some statistics later, but basically on a regular Windows machine, again, just looking at these executables on the OS and other Microsoft products, the number of executables you're going to find is over 3,000, and scripts that you might find, so 3,000 of those. So manually trying each one of these is just not feasible. So the approach that he took was initially to just develop some very basic Python scripts, and we can see here the Python script running. He started an HTTP server on the box, and again, we're looking at the download phase now. Which binaries allow you to download some binary from there. And again, very straightforward one. In this case, just putting the file name, the executable name, and some URL, and see if it recognizes it, and it will do something. And we can see here that it did. If you're curious, this MSOHTMED, it's a very old tool that was used to print HTML pages without having to show the print prompt. But it does allow you to just download download whatever you want directly, just by passing the URL to as a command line argument to the executable. So we see to download this. So this is the manual process, but how do you actually, The next step is obviously to see where it was downloaded to. Usually it's going to download some temporary space or something like that, but again, you can use tools like Process Monitor, or you can monitor the actual file system to see where it was put. In this case, we just use sysinternals process monitoring, and you can see where the create file syscall was made, I shouldn't say syscall, but was made, so where the file was actually saved. So now we have the first part, right? We have a downloader, and we know where the executable was placed. So I can manually, if I have a full shell, I can execute that myself, or I might want to use another executable to do, another LOLBAS to do the execution. Again, even if I do have that full shell that I can run this automatically, I can run this manually, I might still want the executable to be run by another program to be able to hide. So he got into 2 hours of this manual one-by-one approach, a very simple one where we're just looking at the binaries and passing an argument to it and see where it can go. And he was able to find a few more executables that we were able to make the cut to actually go into the project. So if we actually go into the LOLBAS project, it will show this. So there's different executables. Very simple approach. Go to the executable, put an URL, and they were able to download binaries with no restrictions. Again, problem, as I kind of already mentioned, sorry about that, is that are over 3,000 executable files on a base operating system, and that's a normal one without a lot of things installed on it. So how do you get around that problem? Well, solution is, again, automation. Everything in Pentera is about automation, so our processes are also going to go the same way. So the solution that he found was a very simple script, and the idea is for each one of the executables that were on that list, you just go through and you make a request to a local listening host. Same thing that he did manually, but now you have the listener and you put the script to just do this very naive process automatically, right? We can see here just basic Python, right? Just glob, just look at everything that's an executable within those that directory, and then for each one of those, you're gonna use popen, which is just a function from a method, I should say, from a subprocess library that allows you to run the file with whatever arguments you want. Cool. And then on the server side, again, instead of just having the basic server, just something a little more interesting, because the idea was to see not if you can download doc files or anything like that, but if you can download an executable. So again, it would just log. If it was able to see that request to a sample executable, it would do that. It would show the download there. Cool. And it would actually show the path for the file and just save that. Again, very naive approach, but he was able to find 4 more new downloaders. Now, the cool thing is that this is back from the original presentation was for Black Hat 2023, Black Hat Asia, and he was able to find 4 more downloaders. So with those other 3, it was actually a 25% increase in the LOLBAS downloaders project. So again, in 2 hours, he was able to contribute to the project in a very meaningful way. So again, with a very naive approach. Cool. So now to the second task, which was to execute. Because again, even though you might be able to execute it yourself if you have a shell, it might be still interesting to get one of those signed binaries to actually do the execution. Your EDR, you might be able to trick an EDR into thinking that it was a valid process, and just to stay under the radar, certainly to avoid detection and things like that. It might be interesting to actually find the executable that can do that. Another interesting thing is to look at the actual command line arguments, right, that you can use. Because again, initially it was just the name of the executable and the name and the URL to download that executable from. To download the actual payload from. But what about command line arguments? You might be missing a lot of opportunities if you're not passing the right argument, right? So the approach was to actually augment that process to actually, if you can, I think, yeah, there you go. So the beginning is still the same. We're just going to look at every single executable, but now for every single ASCII low ladder, we're going to basically just try to append this. Again, semi-naive still. We're just brute forcing it and looking, from A to Z, go and try these flags and then try to download the file, right? With a single dash, double dash, and since this is window, with a slash as well, since this is common way to pass parameters on Windows as well. So again, the idea here is to be a little more intelligent and try to do that. And obviously did for uppercase as well, just to be complete. Right? Cool, so let's play another video here really quickly. Because now you have another thing that you want to know. Since you automated the process, and this is to actually execute the binary, how do you know that it's actually being executed, right? It's a little tricky. So the way to do this, or the way that he found initially to do it, was to use process monitor to see if there's a way to identify those, and there is. There is on the snapshot for the binary. It tells you who the parent for the binary is. So I'm just going to play this again really quickly. Once you run a command, so just CMD, and then it's going to run a command from there, just Notepad. And the idea is to if you look at the Notepad process on process monitor, you're able to get the parent. It's right here, right? So you get the parent of that process. So the idea is, since he's running all of these scripts on the command line, he can now use this information to be able to see which ones respond. Which of the executables that we have, the LOLBAS ones that we have, we're able to spawn the process. Right? So the next step was to write a little helper, because you don't want the process monitor file, the sysinternal process monitor application doesn't have an API, so it doesn't allow you to query that remotely. So what he did was write this little executable helper, pretty straightforward. If you're used to the Windows API, it just creates a tool, the tool help snapshot, which just allows you to basically take any process ID and look at the information about that, right? So the information about the process, parent, and all of that information, all of that fun stuff. And what we're looking at here is, if the process ID is the one that I created, then look at the parent of the process and save that, and then just run through every single snapshot that you found, and then just log that to the output. So there you go, get the process name and everything that was started by the CMD process. Cool, so at that point, he was able to find 3 more new executables, right, that were submitted to the LOLBAS project. So SCP1, SFTP. So SFTP was an interesting one because it does have this capital D argument. Yeah. All right, where was I? Okay, the capital D argument is an interesting one because it's actually made to, if you ever run SFTP, it's actually made to bypass the SCP. Sorry, see, I'm getting drunk already. It's made to bypass SSA directly on that. So since this is actually an interesting downloader, you can actually, executor, you can actually run that SCP command to run the executable right away with this -d command with no fuzz or anything like that. So again, this MSO HTMED, that's the one that we use for the downloader, and as you can see, it's also an executable executor as well. So very helpful little binary. Cool. So this is already interesting, but dynamic analysis is cool. It's easier to do, but it's also time-consuming, right? I mean, you saw that for every single executable, you have to run it. And it's also not very elegant, let's be honest, right? So the next step was to look at, I do need the water, was to look at the static analysis flow, right, to get things a little more interesting. So the idea is to reverse engineer the binaries and see if they're a relevant API call. So we see one there, for example, URL download to file W, right, wide, which is just one of the APIs, but you can think of the same thing as create process and all, just look at the API that you're interested in, and we will look at that. Specifically just for that downloaders. So then the idea is to reverse your way all the way to the actual binary, right? To the command line arguments, and you verify if the command was, the value that was given to be downloaded is actually from the user command prompt, right? So make it a little more sense if we do it here. Here's the kind of the analysis. If we walk through it, so the idea is to start at the bottom, right? So you find the APIs, every single API that are relevant to you. Well, you reverse the functions first. You find an API that's interesting to you, and then you kind of walk back and see if it came from the command line or not. Pretty straightforward, right? It's should say that. It's a straightforward idea to go through that. You're looking, if you have familiarity with IDA or any other reversing tool, it gives you very clearly the XREFs, right? So all of the external references to an API call, to a function. So the idea is to follow that back and then find out if it was part of the command line until you get to main, and you should be able to see the command line arguments. So here's kind of the flow chart for how you do that. So again, you start by looking at the XREF for the relevant APIs. So build a list of APIs that you're looking for, build the XREF, decompile the function. Is it on the main function? If it is, you look at the URL itself and see if it was actually gotten from the CLI, from command line argument, right? Or you go through. If it was not, you kind of you kind of just keep decompiling the function that was there, find the reference to it, and keep going that way until you get to main, and then you look at that thing. So it's an interesting approach, but that logic, the bottom logic is not that easy to do, right? IDA Python can do the first one. I'm actually more of a Binary Ninja guy. Binary Ninja actually has a very cool headless library to it that allows you to automate this, so you don't even have to have the UI running. So definitely recommend that. But the idea that Chaco, and at this point the team was actually already started working on it, was to use ChatGPT to do the other part. So basically to iterate and understand the function. Because again, lazy. And this is actually this is a process that we're still developing. It's already given us some results, but it's still being developed inside Pentera, is to use this different approach to be able to get to these functions. So cool. So key takeaways from the talk should be, again, just reiterating what I said before. The idea is for blue teamers and red teamers to find new and unknown LOLBAS. And the approach for researchers to get to a wider range of potential targets, right? Again, this is especially the static analysis way is very scalable. You can run this even in parallel, like again, I'm more of a binary ninja guy, so I know that platform better. You can certainly run it in parallel, where you're analyzing a bunch of executables at the same time. And one thing that we're looking into the future is to use this in kind of a more dynamic way, where I'm looking for, because what we're talking about here are known executables that are going to be on the box. They're OS-based, Office-based, or some tools that are, they're big likelihood they're going to be on the tool. But what about tools that are custom, or not custom, I should say, but not very common? Well, you can kind of do this dynamically. If you have the library that allows you to do the reversing, and it can be Capstone, it could be, what's the name of the other one? Capstone is a big one, Radari, or any of the tools that allows you to do this reverse engineering or decompiling all these functions can be used to get you the same way. So you can imagine building your own tools, uploading to the box, right, and then running these things dynamically so that you find these new executors or whatever functionality you need on the fly on those boxes. Again, this is kind of to what I just said, right? We were looking for very specific things, but you don't have to, right? We're looking for Microsoft signed or native OS binaries to actually do the research on it and script. But you don't have to be tied by that. You can look for whatever you want. You can look at dynamically. You can certainly do this on software that are more common on your organization, right? Custom software that can be used, perhaps, to perform these lessons. Again, hackers don't care about official lists, so it doesn't matter if it's approved by Microsoft or not. If it can be used to achieve the same functionality, you can do it. All right, with, well, I guess a minute left, I am done. So thank you. Oh, come visit us if you haven't already. Thank you.